This is problem number 3 from section 9.4. It says use Gaussian elimination with backward substitution to solve the system of linear equations. We need to write these linear equations as a augmented matrice. So we're going to start by saying 1, 1, negative 1, negative 1, negative 1, 4, negative 3, 9, and then 5, negative 5, 1, negative 17. Now remember, we need to start in the bottom left-hand corner, trying to get that to be 0. Now technically we could just start right here and get this one here, but let's start at the bottom. That's just how I like to do things. So I'm going to multiply the top row by negative 5, so negative 5, R1, and that's going to give me negative 5, negative 5, 5, 5, leaving you with negative 1, 4, negative 3, and 9, 5, negative 5, 1, negative 17. Now I'm going to add row 1 plus row 3 equal row 3. So that's going to give you row 1 and row 3, that's 0. This will give you negative 10. This gives you 6. And this will give you negative 12. Leaving you with negative 1, 4, negative 3, 9. And then on top, you're going to have negative 5, negative 5, 5, and 5. Now I'm going to multiply the top then, because I got to cancel this middle be 0. I'm going to multiply this by negative 1/5 R1. That's going to give you 1, 1, negative 1, negative 1. Back to the beginning. Negative 1, 4, negative 3, 9, 0, negative 10, 6, negative 12. I'm going to take row 1 and add it with row 2 to get row 2. When you do that, you end up with 0, 5, negative 4, 8, 1, 1, negative 1, negative 1, and 0, negative 10, 6, negative 12. So now I need to multiply the middle row by 2. So I'm going to do 2R2. And that's going to give you 0, 10, negative 8, and 16. We have 0, negative 10, 6, negative 12, and 1, 1, negative 1, negative 1. Now I'm going to take row 2, add it with row 3, and that's row 3. All right, I'm going to squeeze this one in. So we're going to get on the bottom 0, 0, negative 2, and 4. Middle row 0, 10, negative 8, 16, and 1, 1, negative 1, negative 1. Now all we got to do is multiply by basically 1/10 and negative 1/2. So we're going to get 1/10 R2, and we're also going to do negative 1/2 R3. So on the bottom we get 0, 0, 1, negative 2. Middle row we get 0, 1, negative 8 over 10, and then 16 over 10. And at the top we still have 1, 1, negative 1, negative 1. All right, let's write the three equations out and use some backward substitution. So we have z equal negative 2. We have y minus, this is actually 4/5, so I'm going to write 4/5 z equals 16 over 10 divided by 2, you get 8 over 5. And then we end up with x plus y minus z equals negative 1 for the third equation. So this is bottom row, middle row, top row. Take this, plug it in, we end up with y minus 4/5 times negative 2 equals 8/5. This ends up being y plus 8 over 5 equals 8 over 5. So you end up with y equals 0 when you subtract it over. Now we're going to take both of these, plug them in here. So you have x plus 0 minus negative 2 equals negative 1. This will give you 8, or x plus 2 equals negative 1. Subtract it, x equal negative 3. Write your ordered triple then, so we end up with negative 3, comma, 0, comma, negative 2. And that's your solution for the problem.